Welcome to lecture 7 of module 4, and today we are going to discuss about the topic border gateway protocol. Okay, so this is an inter-domain routing protocol. In the last video we have discussed about the intra-domain routing protocol. So what is intra-domain routing protocol? So in the last video we have told about the intra-domain routing protocol, that is the routing performed within an autonomous system. Okay, so this is an autonomous system, this is another autonomous system. Okay, so how this routing performed between the autonomous system? This is autonomous system 1, this is autonomous system 2. So how routing performed between these autonomous systems? That is done using the protocol called BGP, Border Gateway Protocol. Okay, so don't confuse with the terms. The routing performed within an autonomous system is called intra-domain routing protocol. Okay, the intra-domain routing protocol we have learned is OSPF. Okay, the routing between the autonomous systems, routing between these autonomous systems is done using inter-domain routing protocol, that is called BGP. Okay, a BGP is an inter-domain routing protocol. Okay, so border gateway protocol. So border gateway protocol BGP is an inter-domain routing protocol using path vector routing technique. Okay, so here we are using the technique called path vector routing. Okay, path vector routing technique. So we'll explain what is path vector routing. Okay, so before that you will see the different classification of autonomous systems. So we can divide the autonomous systems into three categories. Okay, stub, multi-homed and transit. So what is a stub, what is a multi-homed, and what is transit? Let us see. Let us explain this concept with a figure. Okay, this is a figure. So in this figure we here these are autonomous systems. Okay, these are autonomous systems, and from this figure, this autonomous system 1 and this autonomous system 5 are stub networks, which means that a stub network means that it has only one connection to other autonomous systems. See here, this autonomous system and this autonomous system, there is only a single connection between this autonomous system and system 1 and 3. Okay, so such autonomous system is called stub systems or stub autonomous system. Okay, clear? A stub autonomous system has only one connection to another autonomous system. So this autonomous system is having only a single connection. This autonomous system is also having single connection. But look at here, this autonomous system is having two connections to this autonomous system and to this autonomous system. Okay, this is also having two connections to this and to also to this. So this AS3 and AS4 are not what? They are not stub autonomous system. Okay, so this is called a stub autonomous system. A stub autonomous system has only one connection to another autonomous system. Okay, let us see the details. Stub autonomous system. A stub autonomous system has only one connection to another autonomous system. Data traffic in a stub autonomous system can be either created or terminated in the autonomous system, which means that the data traffic can be generated from this autonomous system. Look at this figure. The data traffic can be generated from this autonomous system, okay, and moved to any other autonomous system, and also can be terminated from other autonomous systems. The traffic can be coming from other autonomous systems and can be terminated to this autonomous system. Okay, that is the meaning. Okay, the interdomain traffic in a stub autonomous system can be either created, okay, either created from this autonomous system, or either can be terminated to this autonomous system. Okay, the next point is the host in the autonomous system can send data traffic to other autonomous systems. Okay, so the host present in this autonomous system can send traffic to any other autonomous systems. Okay, similarly, the host in the autonomous system can receive data coming from other autonomous system. Okay, a host present in this autonomous system can receive data from any other autonomous systems. Okay, ഇപ്പോൾ ഇവിടെ ഒരു ഹോസ്റ്റിന് പുറത്തോട്ടുള്ള ഏത് ഓട്ടോണമസ് സിസ്റ്റത്തിലേക്കും പാക്കറ്റ് സെൻഡ് ചെയ്യാൻ പറ്റും. അതുപോലെ ഇതിനകത്തിരിക്കുന്ന ഹോസ്റ്റിന് എവിടെ നിന്ന് വേണമുള്ള ഓട്ടോണമസ് സിസ്റ്റം ഇവിടെ നമുക്ക് ഇതിനകത്ത് സെൻഡ് ചെയ്യാം. നെക്സ്റ്റ് പോയിന്റ് ഈസ് A data traffic, however, cannot pass through a stub autonomous system. Okay. അപ്പോൾ ഈ സ്റ്റബ് ഓട്ടോണമസ് സിസ്റ്റം വഴി വേറെ ഒരാളുടെ ട്രാഫിക് അതുവഴി പാസ് ചെയ്ത് പോകാൻ പറ്റില്ല. ഓക്കെ, ദ സ്റ്റബ് ഓട്ടോണമസ് സിസ്റ്റം cannot പാസ് ദ ട്രാഫിക് ഓഫ് അതർ ഓട്ടോണമസ് സിസ്റ്റംസ്. ഓക്കെ, അതുവഴി പാസ് ചെയ്ത് പോകാനുള്ള പെർമിഷൻ ഇല്ല. ഓക്കെ, ഡാറ്റ ട്രാഫിക് cannot pass through a stub autonomous systems. Clear? So this is called a stub autonomous system. Okay, so stub is having only one connection with the other autonomous system. Okay, a traffic can be either created from this autonomous system or can be terminated to this autonomous system. Okay, the next point is an autonomous system a host in the autonomous systems can send data to any other autonomous systems. Similarly, the data from any other autonomous systems can be reached to a host in this autonomous system. Okay, clear? So data traffic cannot pass through any autonomous system. Okay, ഒരു സ്റ്റബ് ഓട്ടോണമസ് സിസ്റ്റം വഴി ഒരു ട്രാഫിക്ക് പാസ് ചെയ്ത് പോകാൻ പറ്റില്ല. ഓക്കെ, പാസ് ചെയ്ത് പോകാൻ പറ്റില്ല എന്ന് പറഞ്ഞാൽ എന്താണ് എന്ന് പറഞ്ഞാൽ ഇപ്പോൾ ഓട്ടോണമസ് സിസ്റ്റം 3യുടെ ട്രാഫിക്ക് ഇപ്പോൾ 4 എത്തേണ്ടത് നമുക്ക് ഇതുവഴി പോകാൻ പറ്റില്ല. ഓക്കെ, ഓട്ടോണമസ് സിസ്റ്റം 3യിൽ എത്തേണ്ട 3-ന്ന് 4ലേക്കുള്ള ട്രാഫിക്ക് cannot be diverted through this AS1 because AS1 is a stub network. Okay, that is the meaning. Clear? Next one is multi-homed autonomous system. A multi-homed autonomous system has more than one connection to other autonomous systems but is still only a source or a sink for data traffic. Okay, so what is the meaning of that? Look at here, look at this figure. Here this multi-homed, so this here is AS2. AS2 is multi-homed autonomous system. Okay, it means that it can have more than one connection to other autonomous system. This is having a connection to this one and also having a connection to this one. Okay, this or such autonomous system is called what? Multi-homed autonomous system. Okay, so what is a multi-homed autonomous system? It has more than one connection to other autonomous system. Okay, and another point is saying that it is still only a source or a sink. Look at the statement, but it is still only a source or a sink. So source or a sink means what? It can generate the traffic. It can generate the traffic and also terminate the traffic, but it cannot pass the traffic of one autonomous system to another. Okay, ഇപ്പോൾ ഇവിടെ നിന്ന് ഒരു ട്രാഫിക് ജനറേറ്റ് ചെയ്യാം, ഇവിടെ നിന്ന് ട്രാഫിക് ടെർമിനേറ്റ് ചെയ്യാം. ഓക്കെ, പക്ഷേ വേറൊരാളുടെ ട്രാഫിക് ഇതുവഴി പാസ് ചെയ്ത് പോകാൻ പറ്റില്ല. ഓക്കെ, ഇപ്പോൾ AS3യുടെ ട്രാഫിക്ക് ഇതുവഴി പോകാൻ പറ്റില്ല. ഫ്രം AS3 to AS4 the traffic cannot move from this way. Okay, clear? So this cannot be a transient autonomous system. The traffic cannot pass through this autonomous system. It can create a traffic and also terminate a traffic. അതാണ് ഇവിടെ സോഴ്സ് ഓർ സിങ്ക് എന്ന് പറയുന്നത്. ഓക്കെ, കണ്ടോ? It is still only a source or a sink for data traffic. The traffic can be generated from that autonomous system and also can be terminated to that autonomous system. Okay, it cannot pass the traffic through that autonomous system. It can receive data traffic from more than one autonomous system. It can send data traffic to more than one autonomous system. Okay, it can receive data traffic from different autonomous system. ഈ autonomous system 3 എന്ന് കൊടുക്കാം, 4 എന്ന് കൊടുക്കാം, 5 എന്ന് കൊടുക്കാം. It can receive traffic from any other autonomous system. Okay, and also it can send traffic to more than one autonomous. It can also send traffic to more than one autonomous system. Okay, next point is it does not allow data coming from one autonomous system to go into another autonomous to pass through. Okay, അപ്പം വേറൊരു ഓട്ടോണമസ് സിസ്റ്റത്തിൻ്റെ വേറെ രണ്ട് ഓട്ടോണമസ് സിസ്റ്റത്തിലേക്കുള്ള ട്രാഫിക് അതുവഴി പാസ് ചെയ്ത് പോകാൻ സമ്മതിക്കില്ല. ഓക്കെ, the traffic from this autonomous system to this autonomous system 4 cannot pass through this autonomous system 2. That cannot be allowed in a multi-homed stub network. Okay, that is the third statement. A good example for a multi-homed autonomous system is a large corporation that is connected to more than one regional or national autonomous system. Okay, suppose a multinational companies will be having offices at different areas. They'll be having offices in Trivandrum, India, or in UAE or in US. Okay, so in that case, what they do, they'll be using this multi-homed autonomous systems to connect their head office and to their various annex. Okay, so this is a very good example for multi-homed autonomous system. Clear? Now the last one is a transit autonomous system. So transit autonomous system is also a multi-homed autonomous system, but that allow transient traffic. So what do you mean by transient traffic? So transient traffic means it will allow the traffic from other autonomous system to pass through it. That is called a transient traffic. So transient traffic will be permitted in transit autonomous system. So look at the figure. So here autonomous 3 and 4 are transit network. 3 and 4 are transit network. Okay, which means that the traffic from other autonomous system can be passed through this node. Okay, for example, if you want to move a traffic from autonomous system 1 to autonomous system 5, it will be moving through autonomous 3, okay, AS3, okay, then AS4, then to AS5. Okay, clear? So this is the meaning. So a traffic from this can be passed through. Suppose a traffic is generated from AS2, want to pass it to AS5. Then it will be moving to AS4 and then to AS5. Clear? So the transient traffic is actually permitted in this in the transit network. Clear? Okay, so this figure will explain all these concepts in detail. Okay, you just explain these concepts and draw this figure. That will be enough. So this is the classification of autonomous systems. Okay, this is the classification of autonomous systems. Now we are going into the details. Of border gateway protocol. We have already learned that border gateway protocol is using a path vector routing algorithm. Okay, so what is that path vector routing algorithm that we are going to see now? Path vector. So path vector means that instead of maintaining just a cost of the route, okay, we have already learned that between each router will be there will be a metric called cost will be assigned by the administrator. Okay, the path vector says that we have, in addition to that cost, we are keeping another thing along with the cost, that is called a path vector. Okay, so we are maintaining, instead of maintaining just the cost of the route to each destination, each BGP router keeps track of the path used. We are also keeping track of the path used. This approach is called path vector protocol. Okay, so it will be more clear by looking at this figure. So this is an autonomous system. It will be having many networks, combination of routers and networks. This is another AS, this is another AS, and this is another AS. Okay, here a packet is being transmitted from here to here, from this autonomous system to this autonomous system. So the packet is being starting or initiated by this autonomous system 65400. Okay, so when this reaches here along with the address, they are giving the details from where this packet is being coming. The packet is coming from AS 65400. That is also mentioned here. Okay, so after passing through this second autonomous system, that is 65300, it will be moving to this one. Okay, so when it reaches here, it will be containing the path information saying that first it is being started from 65400, then it passed through 65300. Okay, now finally when it reaches here, when it reaches the last autonomous system, it will says that the path is also mentioned here, that it says that it generated from 65400, It came through 65300 and also it came through 65200. Okay, by reading this information, we get the path through which this packet has been traveling. So when a packet reaches here, it will get the details of the path through which it has traveled. Okay, it is initiated from 65400, travel through 65300, then finally to 65200. Okay, so this is called the path vector. Okay, this is the statement that is explained here. Instead of maintaining just the cost of the route to each destination, each BGP router keeps track of the path used. Okay, this approach is called path vector protocol. The path consists of the next hop router and the sequence of autonomous systems or autonomous system path that the route has followed. Okay, the path contains the next hop. Again, along with the next hop, it will gives the sequence of the autonomous systems. Okay, sequence of autonomous system, that is, autonomous system is having, each autonomous system will be having a unique identification number that will be given along with that route. Okay, clear? So this is called the path vector method. Now BGP session. There is another method called BGP session, another concept called BGP session. So what is BGP session? The exchange of routing information between two routers is done using a BGP session. If the two routers want to communicate, or two routers want to send a packet, send information between them, then they will be create a session. Session means a connection. Okay, after creating the session only they can have the information to be passed. Okay, so the BGP takes place in a session. A session is a connection. So look at here, session is a connection that is established between two BGP routers only for the sake of exchanging routing information. Okay, so why this BGP session is taking? This is BGP session is taking for in exchanging the routing information. Routing informations അങ്ങോട്ടും ഇങ്ങോട്ടും ട്രാൻസ്ഫർ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് ഈ ഒരു സെഷൻ അവർ ക്രിയേറ്റ് ചെയ്യുന്നത്. Okay, so BGP session, which is being created by the routers to exchange the routing information between them. Okay, to create a reliable environment, BGP uses the service of TCP. Okay, ഈ സെഷന് വേണ്ടിയിട്ട്, in order to create this session, they are creating this session using a TCP connection, transmission control protocol connection, TCP. Okay, അത് റിലയബിലിറ്റി എൻഷുർ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് അത് ആ TCP അവർ ഉപയോഗിക്കുന്നത്. Okay, so in order to create this session, they are using the TCP method. When a TCP connection is created for BGP, it can last for a long time until something unusual happens. The TCP connection established ചെയ്ത് കഴിഞ്ഞാൽ, when it is created, it can last for a long time until some congestion or any other activity or unfair activity happens. Okay, for this reason, BGP sessions are sometimes referred to as semi-permanent connection. So BGP connection sessions are also known as semi-permanent connection. Okay, that means that until something unusual happens, the TCP connection will be established. Okay, so that is called a BGP session. BGP session is nothing but a connection that is used for exchanging the routing information. Routing informations അങ്ങോട്ടും ഇങ്ങോട്ടും പാസ് ചെയ്യാനാണ് ഈ ഒരു BGP sessions ഉപയോഗിക്കുന്നത്. Okay, clear? So this is the explanation for the border gateway protocol. Okay, so border gateway protocol is actually, the main concept is the path vector. Path vector is actually the concept here, and also you have to explain about the BGP session. Okay, so these are the two protocols for inter-domain and inter-domain routing. Okay, thank you.